chapter. Okay, so let's quickly discuss the basics first. What is experiment? An operation which can produce some well-defined outcomes is called an experiment. Okay, it should be a well-defined outcome. Well-defined outcome means, let's say if I'm tossing a dice, is my voice clear now? Okay. Prasanjit, they have not uploaded the last video also. I'm still waiting for the last video since last 2 weeks. We started our class from last week. But anyways, after the session, I will have a talk with them, okay? So now, experiment is an operation in mathematics which can produce some well-defined outcomes. Like when I toss a dice, I will get on a well-defined number on the top, and that number will be either 1 or 2 or 3 or 4 or 5 or 6. Similarly, when I will toss a coin, I will either get a heads or I will get a tails. Okay, it will not be like that the coin is in between and you don't get to see a head or a tail on top. You will see a clear-cut, well-defined outcome. Okay, a random experiment. A random experiment is an experiment in which all possible outcomes are known and the exact output cannot be predicted in advance. So in probability, we always deal with random experiment. Okay, or the questions which you're going to get in your aptitude test will always include random experimental events. Okay, where the outcome cannot be decided beforehand. You know all the possible outcomes, but you don't know which outcome has more chances of coming. All the outcomes are equally likely. Examples are of rolling an unbiased dice or tossing a fair coin. What do you mean by a fair coin? It simply means that like the coin does not have any kind of damages or some changes in the shape. Okay. Similarly, what does an unbiased dice mean? It means that all the 6 faces has different numbers. No 2 faces will have the same number. Okay. So then we have sample space. You must have read about sample space also. What is sample space? When we perform an experiment, then the set of all possible outcomes is called the sample space. Like when you toss a coin, you get either a head or a tail. So the sample space of tossing a coin will have two objects in it. Okay. Similarly, if we are tossing 2 coins, then the sample space will contain 4 outcomes. If you're rolling a dice, the sample space will contain 6 outcomes. Okay. And what is an event? It is any subset of a sample space. These things are, guys, not that important. You just need to have a decent idea about sample space. And then what is probability? I believe everyone knows the formula of probability: number of favorable outcomes divided by total number of possible outcomes. And what is the definition of probability? It is the measure of the likeliness that an event will occur. Okay, it gives us a chance of happening of an event, and the value of probability always lies between 0 to 1, where 0 indicates impossibility, where the event is impossible, and 1 indicates certainty, where the event will definitely occur. Okay, higher the probability of an event, the more certain that the event will occur. So there are certain results on probability which you need to know. If we want to find out the probability of sample space, that will be 1, because if the total number of possible cases are x and we are finding the probability of a sample space, in that case the number of favorable numbers is also x. So x by x will give you 1. The value of probability will always lie between 0 and 1 for any event a and b. P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay, this means A intersection B. So guys, this AUB means A union B. This is what we read in class 11th in the first chapter of sets. Union means either A or B or both. Okay, you can say or is there, either A or B or both. A intersection B means both A and B. Okay, and last step says if A denotes probability of A plus probability of not happening of A. Basically, probability of happening of an event plus probability of not happening of an event, the sum will always be equal to 1. Okay, probability of happening of an event plus probability of not happening of an event will always be equal to 1. Let's say you have performed some experiment, and let's say the probability of happening of that experiment is, let's say, 1 by 7. Okay, so the probability of not happening of that event will be 1 minus 1 by 7. Okay, this is what will help. Now uh, coming to the types of questions, so you will get questions, uh, there will be basically only 4 types of questions which you can get in probability. The first one will belong to the coin. Okay, second will be based on the dice, third one will be based on a pack of cards, and the fourth one will be based on selection of let's say different colored balls from a pack. Okay, so these are the 4 possible questions, types of questions which comes from this topic. First one is based on coin, second one is based on dice, third one is based on pack of cards, and the last one is based on simply taking out of different color balls from bags. Now, when we throw a coin, you get either heads or a tail. And when you toss a dice, you get 1, 2, 3, 4, 5, or 6, right? And when we throw a die, the outcome is the number that appears on its upper face. So these 2 things, I believe everyone is clear. Now coming to the pack of cards, you need to have a very good idea of the contents in a pack of cards. No, nothing like spinning win alone. So a pack of cards has 52 cards in it, and these 52 cards are divided into 4 different suits. The suits are named as spades, clubs, hearts, and diamonds, where cards of spades and clubs are called as black cards, and cards of hearts and diamonds are called as red cards. Okay, then there are kings, queens, and jacks in every suit. These are called as face cards. Now guys, a lot of people, they confuse when they come across the definition of face cards. Whenever you get a question based on face card, you always need to consider kings, queens, and jacks. You will never consider an ace in face card. Okay, because ace, if you have a pack of cards, you can just check it out. You have only kings, queens, and jacks cards where the faces are made. You don't have faces on the cards of ace. Okay, so whenever you come across face cards, you will always go for kings, queens, and jacks. Okay, so just try out this question. Before this, let's go for some simple questions. Go for this question. What is the probability of drawing 2 cards from a well shuffled pack of 52 cards? What is the probability of drawing 2 clubs from a well shuffled pack of 2 cards. Wrong. It will not be 2 by 52. Okay. Now one more thing which you should have asked me, that sir, like the 2 cards which we are drawing from this pack, are we doing it one go or we are doing it one after other? This question can have 2 parts. First one, where we have taken the 2 cards at the same time, where we have taken out the 2 cards simultaneously. Okay. And the other part of the question can be where we have taken the cards one after another. So first of all, let's discuss what will be the scenario when we are taking the cards simultaneously. Simultaneously. Right now, you need to focus on simultaneously. So, in simultaneous situation, it's very simple. You are simply taking out 2 cards at one go from 52 cards. Okay. So first of all, whenever I get a question of probability, my approach is that first of all, I try to find out or write down the denominator. Okay. So your approach should be to first of all write down the denominator. Now, what am I doing? I am drawing 2 cards from 52 cards. So what are the total possible ways of withdrawing 2 cards from 52 cards? That is 52C2. Okay. The total number of ways of withdrawing 2 cards from 52 cards is 52C2. So that will come in the denominator. Now coming to the numerator. Now you know that in probability, in the numerator, we write the number of favorable outcomes. And what do we want in this question? We want to know in how many ways can we draw 2 clubs. So now you need to think that in a pack of cards, how many clubs do we have? Now, how many clubs do we have, guys, in a pack of cards? How many clubs do we have? Deepti, Gayatri, Suryadev, Abhishek, Manasvi have answered 13. Rohan has answered 13. Right. So we have 13 clubs. We have 13 clubs, right? Clubs is a suit. I told you that a suit, like a pack of 52 cards is divided into 4 different suits, and every suit has 13 cards in it, right? So from those 13 clubs, I need to draw 2 clubs. In how many ways can I do that? I can do that in 13C2 ways. Okay. So the number of favorable outcomes is 13C2. The number of total possible outcomes is 52C2. So my probability will be 13C2 by 52C2. Okay. So I hope this is clear. Okay, guys, now this is the scenario where we are withdrawing the cards simultaneously, right? At one go. Now, just imagine that you are withdrawing 2 cards, but you are withdrawing one after another. It means initially there were 52 cards. From those 52 cards, you took out 1 card. Okay, you kept it aside. And now from the remaining 51 cards, you took out the second card. Okay. Now in this case, the question is to find out the probability of drawing 2 clubs. So now tell me what will be the answer if it is one after another. Sam, in this case, choosing a particular suit is not important because it is already mentioned that you need to take out clubs. If the question was for, let's say, kings, so the selection of suit would also have been counted. But in this case, it is only this clubs. So selection of suit does not come. Yes, Gayatri and Abhishek have answered it correctly. Abhishek, no, this will not be a plus in between. Na? Plus will always only come when it is or. Sam, 52C2, again you are doing a mistake there. So, okay, now let's start with the discussion. First of all, the possible mistakes that one does in this question, okay? Like some of you have written 52C2 in the denominator. Now guys, what is 52C2? 52C2 means two cards, selection of two cards from 52 cards. Are we doing that? Are we doing that in this particular scenario? We are not doing that. We are drawing one card after one card, right? So we are not withdrawing two cards at a time. So 52C2 will not come in the denominator. Okay. Now coming to the question, since we are drawing a total of two cards, but we are drawing it how? We are drawing it one after the other. So first of all, you will find the probability of the first event. And what is the first event? The first event is withdrawing one club from a pack of cards. Now, how many clubs are there? There are 13 clubs. So the possibility of withdrawing the first club is 13 by 52. 13 by 52 is the probability that the first card which you have taken out from the pack of card is a club. Okay. Now, what am I going to do? I'm going to keep that card aside. Now I will again withdraw one card, and again my focus is for a club. So now what is the possibility? That now we are left with 12 cards, 12 clubs. So from those 12, I am going to withdraw one club. What is the probability now? 12 by 52. So 12 by 52 is the probability that the second card is a club. And since the question is to find out the probability that both are clubs, so the answer will be 13 by 52 into 12 by 51. Okay, 13 by 52 into 12 by 52, 12 by 51. Why did we go for multiplication? Because the withdrawing of the first card and the second card has been done in succession. So the will be used here. Is it clear, guys? Is it clear now? What is the approach for this particular question? Please try not to go for those 52C2. Okay, try to make yourself clear that 52C2 is withdrawing two cards simultaneously from 52 cards. Okay, so next question, when two coins are tossed simultaneously, what are the chances of getting at least one tail? When two coins are tossed simultaneously, what are the chances of getting at least one tail? Great, good responses. Everyone is giving the correct answer. While discussing sample space, we already found that the sample space of tossing two coins has four objects in it, right? The like the outcomes are head head, head tail, tail head, and tail tail. So the probability would be 3 by 4. Okay, so this was a simple question. Here's the next question for you guys. Try out this question. In a drawer, there are 4 white socks, 3 blue socks, and 5 gray socks. 2 socks are picked randomly. What is the possibility or probability that both the socks are of same color?
Two socks are picked randomly. So this is a scenario of simultaneously, okay? Gayatri, Sam, and Himanshu. Your answers are correct. Yes, everyone is getting the correct answer. Yeah, Suryadev, I'll explain it now. So, uh, the question is that four there are four white socks, three blue socks, and five gray socks. So we have a total of 4 plus 3 plus 5, 12 socks, out of which two socks are picked randomly. So first of all, what will be the total number of possible outcomes? That will be 12C2, because we have a total of 12 socks here. So 12C2 will come in the denominator. Now coming to the numerator. Numerator has the total number of favorable outcomes. And according to the question, we need to find out the possibility that both the socks are of same color. Same color, so it means I need both the socks to be either of white color or blue color or gray color. So the word or is coming here, right? So basically we will count the cases for white, we will count the cases for blue separately, we will count the cases for gray separately, and we will add them. We'll add all the three because the word or is coming here, right? So from four white socks, in how many ways can you pick two white socks? That will be 4C2. Similarly for blue, it will be 3C2. For gray, it will be 5C2. And since it can be either white or blue or gray, so the answer will be 4C2 plus 3C2 plus 5C2. That will come in the numerator. After solving, the answer comes out to be option D, 19 by 66. So is it clear now, guys? Is the question clear? Suryadev, is it clear? Okay, guys, I have one more question, a very common question. You might have also heard it. So listen out to the question. What is the probability of having 53 Sundays in a non-leap year? What is the probability of having 53 Sundays in a non-leap year? Okay, guys, you have seen the question and you remember the answer, but you wrong. Don't remember the exact. Manu says, Sam, you're wrong. Try to remember the answer. A non-leap has 365 days. Gayatri, 52 by 365 will be wrong.
Okay, so let's look into the solution. I have written it, a non-leap year has 365 days, okay? And if we break it in terms of weeks, 365 days is equal to 52 weeks and 1 day, okay? It is equal to 52 weeks and 1 day. Now the question is to find out what is the probability of having 53 Sundays in a non-leap year. So guys, since we have 52 complete weeks, so those 52 complete weeks will have 53 Sundays for sure, right? No doubt in that. So the entire question is actually dependent on that extra day. Is it clear till this part? 365 days is equal to 52 weeks and 1 day. Now 52 complete weeks will have 52 Sundays for sure. So the extra Sunday will depend on the 1 day which is uh, extra from those 52 weeks. Okay. Now think about that 1 day. What is the possibility that that 1 day can be a Sunday? It will be 1/7 now, because that extra day can be either Sunday or Monday or Tuesday or Wednesday, Thursday, Friday or Saturday, right? So that extra day can be either of the 7 days. It can be either of the 7 days. So 7 will come in the denominator. And what is favorable? Favorable is that I want a Sunday. So from the 7 days, what is the favorable number of outcomes? It is only 1. So that is why it will be 1/7. Okay. And if the question was regarding instead of non-leap year, if it was a leap year, then the answer would have been 2/7, because now a leap year means 366 days, which is equal to 52 weeks and 2 days. 52 weeks will have 52 Sundays. Now coming to this 2 extra days, either of the 2 days can be a Sunday, right? Either of the 2 days can be a Sunday. So that is why in this case, when it is a leap year, the answer is 2/7. But if it is a non-leap year, then the answer is 1/7. So is this clear, guys? This question comes quite often, quite often. Okay, great. So, so guys, I'll end the session here then. If you have any